that is the diagram coming up, unless it's, I stopped. Okay. So there you have 20 microcoulombs, but yet when I started doing the question, I put it as 40 because of that number 40 there, okay? And then I had to go back and correct it. So it's 20 microcoulomb there. These are the two forces. I call them F1 and F2. If that makes sense. Right? Both attracting it? Okay. And then I will resolve F2 into two components, because F2 is the force that's inclined. So I resolve it into F2 sine and F2 cos theta. You'll see that. And then F2 sine theta is the vertical component, and the horizontal F2 cos theta. Okay. Now, Fx, there's only one component along the x-axis, so I call it Fx, which is F2 cos theta. But there are two components along the y-axis, which will be F1 plus F2 sine theta, isn't it? Let's stop there and see how much you understood, because along the y, there's already F1, right? And there's also, what? There's also F2 sine theta. So along the y, you'll have F1 plus F1 sine theta. Am I right?
Why F1 sine theta?
Why F1?
Wouldn't it be F2 sine theta?
Now look at where the theta is. I mean F2 sine theta.
Okay, yeah.
Oh, that's a mistake.
Yeah.
I corrected it. F1 plus F2 sine theta. Oh, is that why you were all so quiet? Okay. F1 plus F2 sine theta. And then find F1 using K Q1 Q2 by R squared, which I have done. Microcoulomb is changed into coulombs, and the other one is an electron, and that's the charge of the electron, okay? So divide by 0.3 squared, and I get it as 1600 times 10 to the negative 16 Newton. That's F1. Similarly, do the same for F2. You would use the same formula, and then get it as, now that's where I made that mistake. Did you notice? Yeah, because I had the 40 centimeter there, but I went ahead and corrected it later on when I noticed that. You see that? Okay. So don't worry about that number. That's not what you're going to get. It was some time before I noticed the mistake. So that's how you get F2. And then Fx is F2 cos theta, so I carry this mistake there, and I have to correct that also later on. And cos theta is 0.8, isn't it? Because cos theta is 4 divided by 5, it will be 0.8. So that's how that comes. So that's Fx, uncorrected. Then Fy is F1 plus F2. That's probably where I noticed when I wrote that. See? When that number repeated, that's when I noticed that that's supposed to be F2, so I've corrected it there, F2. Okay. And sine theta is 0.6, isn't it? Because sine theta is 3 divided by 5. Okay. So that's Fy. Again, uncorrected. Now I think I noticed that Fy around this time somewhere when I was. Yeah, you have to take the square root of Fx squared plus Fy squared, don't you? The idea is correct. That's when I noticed that I had put 40 there. So I went ahead, changed that to 20. That was easy because all I had to do was take half of this. Okay, so I did that every place and got the right numbers now. I didn't want to go back and write the whole stuff again, so I just. And so my final answer that I get with all that is coming up 2.46 times 10 to the negative 13 Newton. Here's number 3. This is believing that you have read the question, you try to look at it and so on. Capacitance, like I told you, it's a paddle plate capacitor, so you use the formula for capacitance and actually find its capacitance. You know the case 1 for air. So find its capacitance. That's the capacitance I got. And then you know that voltage is Q by C, isn't it? The charge is given, so microcoulombs, put that and divide by the capacitance, you get the voltage. And then the voltage can be connected to the electric field. So that's how many volts. And then electric field intensity is voltage divided by a distance between the plates. So just plug in those numbers. Remember to convert millimeter into meter and all that, and you get the answer. (5.6 times 10 to the 4). You have to have this set up like that. The electric field is along the y-axis, positive y. It's a vector. And you have the surface parallel to the YZ plane. Is that correct? YZ plane, parallel. So they are parallel to each other. And flux is given by E dot dA, by Gauss law. E dot dA is E dA cos theta. And in this case, I want to stop. I could not stop right on time. How do you explain that theta is 90?
Because I was seeing it was like up the y-axis and the yz is going to be like, so going to be like a corner of a room.
Cos 90 is? Zero. So that's why you get the answer as 0 Newton per coulomb. Number 6, you have to find the electrical potential energy. If you do not read the question, you don't get it. That's all there is. The relation between potential energy and potential is given there. U is equal to V times Q. That's the relation that you know. And the potential is given as 40 volts. And you are placing a negative 8 microcoulomb charge there, so all you got to do is multiply those to find the potential energy. And it's going to be negative that. All right, maybe the figure gives you a better idea. 800 volt per meter, that means the potential drops as you go that direction. At x is equal to 0, you have 2000 volt. At x is equal to 2, you have to find the potential. That is a potential drop. For every meter, it drops by 800 volts. Therefore, after 2 meters, it drops by 1600. And therefore, what remains is 400 volt. I had to draw the figure again. Negative 2, 4, 6, and at that point you have to find the electric potential. Well, you know that to find the electric potential, you have to imagine that there is a 1 coulomb placed at that point, don't you? Okay? And so the potential at that point P due to negative 2 is this. The formula is KQ by R. There's no R squared. So you need to carry that negative because the potential due to a negative charge is negative. And yeah, that will be 0.28, isn't it? So you get 63.64 times 10 to the 3, and do the same thing for, is it negative 6 or positive 6?
That's positive.
Why I put negative 6? Okay. Thankfully I did not carry that. So here, that's supposed to be positive. But I didn't make a mistake in the calculation, okay? I just put it in. All right, so that's 190. How did I get that easily? All I had to do was multiply that with 3, isn't it?
Yeah.
The distance is the same, so I just multiplied that with 3 and got. And then potential due to 4 microcoulomb. The distance is 0.2 now. Yeah, then I remembered I forgot to put 10 to the 3. So now add them up to find the total potential. Add them up. Total potential at P is the sum of the 3, remembering that one of them is negative, and you can almost see the negative here, can't you? So that comes up to 307.3 times 10 to the 3 volt.
That was electric.
Yeah, one with X and one's with Y.
Oh, okay. Partially.
Yeah, partial. Okay. So you have Vxy, 2xy minus, that's the function. Okay, first take the differential with respect to x. Is that what you get? Remember there's a negative, so 2y minus 2x, and y is a constant, so you get that equation, and then take it with respect to y. We set it equal to 0 because it says that the electric field should be equal to 0. That's why. And of course from that you will get the value of x directly, and then plug it back into that, you will get the value of y. X is 1/2. Plug it into that equation. And you will get y as 1/2 too. We can do this, yes. Okay, here's the answer to number 10. I know you got it, but just for the sake of putting my voice on it, 1,000 electron volts. Change that into joules by multiplying with the charge of the electron. So you get 1.6 times 10 to the negative 16 joules. Answer to number 11. That was the time required, so I had to draw this beautiful diagram. Two microfarad, 4, 6. Those two are in parallel with each other. How do you find the capacitance? Just add them up. So 4 and 6 will give you 10. And then now the circuit becomes the 2 put in series with 10. Isn't it? And so the formula would be,
Over 2 plus over 10.
yeah, but the shortcut is multiply them divided by the sum of them. You know that, isn't it?
I was going to ask you about that. Does that work no matter how many you're doing in series? Or is
No,
it
it's
two?
only for 2.
Only for 2.
Yeah.
Okay. Wait, what?
That shortcut works only when there are 2. C1, C2 by C1 plus C2. The advantage is that the other case you might forget to take the reciprocal. You know what I mean? So it's this one. So you get 1.67 microfarad. I'm just trying to tell you that you have to remember this also. You have to know this. That's the formula for spherical capacitance. 4 pi epsilon naught, the product of the radii divided by the sum, the difference between the radii. The bigger take away the smaller. So you got to remember that.
Oh, wow. We need another one for cylindrical.
Cylindrical, yeah, that involves a natural logarithm. There's going to be natural log b by a. Remember to convert the radii into meter. That's why you find the 0.05 and all that. And then you have to find the charge. Using the potential difference. Find the charge. Multiplication with 100 is easy, isn't it? Just to get it to the format of the multiple choice answers given, it has to be written in nanofarads, so 10 to the negative 9, which is 1.1 nanofarad. All right, first you have to find the capacitance. The capacitance given, 10 millifarad. Change it into farad. You have to find the charge on it. Multiply those two to get the charge. That's 0.2 coulombs. And then find the new capacitance, which is 4 times the original one. That's with the dielectric. And for most people, after this step, the question is, which formula do I use to find the energy? You have to think about which one is constant. Which one? Q. And then you have C. So you have to use the formula that involves Q and C. No shortcut for this. You have to really think this. .5 joules, but the answer is given as in millijoules, so it's 500 millijoules. 14. You have to find the resistivity from that formula. R times A by the length. Just plug in the numbers. The length is 1 meter because it's 100 centimeter. And the answer is 800 times 10 to the negative 6, which is 8 times 10 to the negative 4 ohm meter. As easy as that. All right, 15. Power is square of the voltage divided by the resistance. Rearrange to make resistance the subject and plug in the numbers. 110 squared divided by 100 gives you 121 ohm. Okay, number 16. Energy is VI times time. I did not write the formula. But I put the units. Voltage times current multiplied by time in seconds. 1 hour is 3600 seconds. 6.9 megajoule. And then everything. If you have read the question. It's like there's only a 100 watt driveway light bulb that we are considering. It's on 10 hours per day. Therefore, when you multiply that, the power with time in hours, you get 1,000 watt hour in a day. Okay, and then you have 365 days in a year. Therefore, you multiply that, you get 365,000 watt hours in a year. Now this you have to convert into kilowatt. So you got to divide by 1,000. So you would get it as 365 kilowatt hour. And the electrical company always charges you, when they say 1 unit, that's what they mean. 1 kilowatt hour is 17 cents or 12 cents or 10 cents. In this case it is, how much? 10 cents. Of course it has to be in dollars, so 0.1. And just for that driveway bulb, you had to spend about $36 in 1 year, if it was on 10 hours a day.
Yeah.
18. This is the electrical circuit that you have to draw. First, I did not draw the internal resistance of the battery, but then I did. Look at this. I made the same mistake that I told you not to do. I put that as the. Then I said, cannot fall by that much in real life. You see, cannot fall from 12 volt. In which case the internal resistance would be really high. So now the internal resistance is shown to be in series with the battery there. Is this the formula for current? Because you know that the total resistance will be the sum of the two, 20 plus R, and current is voltage by this. And terminal voltage is will the terminal voltage across the battery be the same as the voltage across 20 ohms? And I know I mentioned this once. You see, although the question says it's the terminal voltage, I'm trying to show that voltage across the external resistance. Do you see that in the picture? Although the number is wrongly shown as 0.3, but do you see? I'm trying to show it here. My question is, will the voltage at this point, that's the terminal voltage, will it be the same as the voltage that I have shown across these two?
Yes.
Will it be the same?
Yes.
Yes, it will be, because those 2 points are exactly the same points. You don't have any electrical component between the two except connection wires. And connection wires have no resistance. That makes sense?
Yes.
So that's how you can do it. Because you really cannot measure the terminal voltage drop of a battery, because that's dropped inside. Okay, so the voltage is current multiplied by resistance. And you just substitute the numbers. 12 divided by 20 plus R times 20 should give you that's just math. And then I realized I put 11.7 volt there. So 240 by 20 plus R is 11.7. So 240, rearrange that to find the resistance. The rest of it is just math. And R is 6 divided by 11.7, almost 0.5. Oh, 0.51 to be exact. Okay, first I had to draw the circuit, of course. Easier to draw that way. And you have to find the resistance between A and B. And that one is 12. You add all those, so I'm drawing it again. You have to draw it several times to make sure you don't make a mistake. So now you have 12 ohms there in place of that.
So you got everything on this one?
Yes, on the 12 and 6 on power.
What, for your
Well,
acres?
could you
No,
consider
what'd you get for the
two,
six?
two, and six,
Two,
and two, and
four.
zero, and do that first?
No.
No? Okay.
So now, remember the shortcut that I gave you? If there are only two, 6 times 12 by 6 plus 12, you know, that gives you 4. So now put those 3 in series with each other. Add them all up. You get 8 ohms as your final resistance. And sure enough, I had to draw this all over again. Believe me, it takes much more time than you see. That's 5 volt. 3, 2, 10, 4, okay. You're asked to find the voltage, the potential difference between that. First, I tried to check whether the given currents are correct. You need not do that. I was just making sure. So, is that right? Gives you another chance to check whether you know how to apply Kirchhoff's second law.
Yeah.
5, negative 10 I1, positive 3, negative 3 I2 is equal to 0. Okay, and I plugged in the numbers that they gave for I1 and I2. Gave I1 as 0.13, isn't it? And I2 as 2.22 plus 8, and sure enough, it comes to 0. Is that fine? Right? Now we have to find the potential difference between A and B. I'm sorry for you, A is at a lower potential than B. Because B is connected to the positive of that battery 3. And the other battery is not even included in that circuit. From between A and B, you don't have the other battery. You only have the battery of 3 volt. Therefore, potential difference between A and B, that's A, that's B. Here is negative 3, and you know why it's negative 3 here?
So you're going.
Okay. And the potential, how did I get the positive 1.3? The current multiplied by the resistance. What's the current flowing? I1 is the current, isn't it? I1 is the current flowing through that resistance, and it's 0.13. 0.13 multiplied by 10 gives you 1.3 volts. So 1.3 volt is dropped there. Right? So you have 0.3 there, you have negative 3 there. And so the difference between these two gives you negative 1.7 volt. That's rather tough to understand. In fact, that's the toughest part of electrical circuits.